The very first time the U.S. government was attacked by a terrorist group was in 1984, when the Rajneesh cult in Oregon contaminated salad bars with salmonella. Salad bars in the 1980s were pretty popular. They were set up so that they were easily accessed by any diner throughout the meal service. But this also made it easy to contaminate them. As a result of contamination with salmonella, more than 750 people became seriously ill. Thankfully, no one died. The reason why the Rajneesh cult was trying to get so many people sick was the group was trying to influence a local election by incapacitating voters in this small town. However, this tactic ended up not being effective, and the culprits were eventually found out. In 2001, we had our next major terrorist attack using bioweapons. Letters containing anthrax spores were mailed to news media organizations and politicians. This specifically seemed to target what were considered to be liberal news media and Democratic liberal politicians, including NBC News and Senator Tom Daschle in the U.S. Capitol. All of this began on September 18th, 2001, exactly a week to the day after the 9/11 terrorist attacks. In the end, 5 people died and 17 people fell ill from anthrax. The FBI and CIA eventually traced the strain of anthrax following its DNA sequence back to sequences known to be associated with U.S. government labs, indicating that this terrorist attack was not from a foreign government, but rather a domestic terrorist that had acquired the anthrax spores by working for the U.S. government. The anthrax deliveries required decontamination of postal facilities that took over 2 years and cost over $200 million. Decontamination was done by fumigating the buildings with chlorine dioxide, a gas that acts like bleach and readily dissipates into the air and on the surfaces of desks and objects. Eventually, in 2008, Bruce Ivins, an individual initially considered a person of interest, was targeted by the FBI as a subject of a warrant for his arrest. Bruce Ivins was a government researcher in the 1990s and was initially investigated for the crime but released due to lack of evidence. Over the subsequent years, enough evidence accumulated that a warrant was issued for his arrest. It was found out that he was emotionally unstable and had targeted pro-choice individuals in the media and the government in other means before. When Bruce Ivins discovered that a warrant had been made for his arrest, he committed suicide by overdosing on Tylenol or acetaminophen before charges were brought, meaning no court trial was ever done trying to convict him, and he was unable to ever defend himself in court. However, despite the fact that Bruce Ivins did commit suicide, the FBI has so much evidence that he was the one responsible that they consider the case closed. If you look back on all the bioweapons used by various militaries over time, there were a few bioweapons that were commonalities throughout history. One of them that we talked about was anthrax. Anthrax is a bacterial agent that's transmitted by a bacterium known as Bacillus anthracis. It's found naturally throughout the world in the soil, where it lives as an anaerobic organism, meaning it prefers to live without oxygen. Because it prefers to live without oxygen, when it is in the soil and exposed to oxygen, it cannot grow very well at all. And so it enters a highly dormant state known as an endospore. Endospores, some people commonly refer to them as spores, are the dormant state of this particular bacterial microbe. This form of the bacterium, when it is in this endospore dormant state, is resistant to UV light, chemicals, and many other agents that would typically destroy a bacterial cell. Not only that, but it can survive for hundreds to thousands of years in the soil, making it very resilient and live a very long time. In nature, Bacillus anthracis usually infects cows or other grass-eating animals. However, it can also infect humans naturally, specifically any person that works in the leather tanning industry or works with the skin of these grass-eating animals can end up getting what's known as cutaneous anthrax, which is when the bacterial cell infects the skin. It ends up causing an open sore on the hand or skin where it's growing, leading to death of that tissue. Cutaneous anthrax can be cured on its own without any medicine at all, but often these days, individuals with cutaneous anthrax will obtain antibiotics to treat it. Now, when this particular bacterial cell is used as a bioweapon, it's usually not used as cutaneous anthrax because, as I said, that disease is self-limiting without even the assistance of modern medicine. Bioweapons versions of anthrax is using the endospores to either put in the food for ingestion anthrax or released into the air as inhalation anthrax. These endospore particles look like a coarse brown powder and can be aerosolized for easy spread of the infection. When they were placed into envelopes, this was intended for inhalation anthrax. It usually does not spread past those initially infected by opening up the envelope, and as a result is good for keeping the bioweapons targeted just to the intended targets. If inhaled, anthrax causes flu-like symptoms, usually leading to death, unless immediately caught and treated with antibiotics. If ingested, it acts like food poisoning, causing vomiting, diarrhea, and loss of appetite, and kills 100% of the people infected by ingestion, again, unless immediately treated with antibiotics. Anthrax can also be avoided entirely with vaccines, although anthrax vaccines come with very nasty side effects and need to be taken annually. And that's why anthrax vaccines are usually just given to people in the US military and not given to US civilians. Now, while anthrax is a modern bioweapon of choice, Black Death, or the bubonic plague, was historically the bioweapon of choice. This is caused by the bacterial cell known as Yersinia pestis. From 1347 to 1351, 1/3 of Europe, or 25 million people, died from this disease. In order to catch this disease, you literally need one bacterial cell to enter your body by a flea bite, making this a highly virulent or very potently disease-causing bacterium. Bubonic plague, or Yersinia pestis, still exists as sporadic outbreaks around the world. This includes the United States, where bubonic plague has been known to infect people by flea bites, even here in the California Sierra Nevada mountains. Every 5 years or so, a couple of individuals will contract this disease. Thankfully today, it can be treated by antibiotics. This microbe not only infects humans, but it also infects rodents and marmots, and is transmitted between these mammals by fleas. When Yersinia pestis, the bacterial cell, infects fleas, it blocks their feeding tubes, causing the flea to get very hungry and continue to try to hop from host to host in order to feed, and in doing so, transmits the bacterial cell to many hosts. Eventually, the flea dies from this infection. When in humans, Yersinia pestis enters the bloodstream and eventually enters white blood cells. The white blood cells are then the home of Yersinia pestis, and rather than being able to attack and destroy the bacteria, become a protective shield. Because the bacteria infect white blood cells, these white blood cells end up getting trapped and accumulate and grow in lymph nodes around the body, specifically the neck, armpit region, and groin or abdomen region. These white blood cells divide, causing swollen lymph nodes, where blood then pools and skin and tissue becomes necrotic or dead, leading to black and swollen lumps around the body. These are referred to as buboes, which is where the term bubonic plague comes from. The incubation period of the bubonic plague is only a few days, and it's, in addition to the swollen lymph nodes, is accompanied by fever, bleeding, and tissue death. Without antibiotics, mortality is over 50%, but with antibiotics, prognosis is generally good. An individual with bubonic plague, someone who acquired it by a flea bite, can transmit it to other people not only through flea bites, but also by coughing or sneezing onto other people. When that happens, an infected individual inhales Yersinia pestis and can end up with pneumonic plague, getting the bacterial cells in the lungs. This mortality rate is nearly 100% without treatment, but again can be treated by antibiotics. If an individual is unfortunate enough to get the Yersinia pestis bacterium into their bloodstream by a cut or abrasion, they can end up with septicemic plague. Septicemic plague has a mortality rate of 100% with or without treatment. I have one brief little note about smallpox in the next section, and then we'll be done.